This scenario illustrates how a data provider on the one hand and a consulting company looking for the best place to sit a solar power plant on the other hand both benefit of using a centralized point of access such as GEOSS.
I am Claire Thomas of Transvalor, a consulting company. I'm a specialist in solar energy and my role is to analyze the potential of a given region for sealing solar power plants. Sealing a solar power plant is a complex process. It implies various actors in a cascade of decision steps where the knowledge of resources plays a crucial role. The process of site selection for the development of large solar systems requires data on solar radiation from which basic economic assessments can be made.
Hello, my name is Lucien Valde from Mines Paris Tech of France. I'm processing satellite data every day, and I'm building databases of solar radiation available at ground level. My concern is the efficient dissemination of my databases, how consulting companies can access my data to exploit them. The GEOSS infrastructure provides solutions and helps me efficiently. Within this pilot phase, the Renewable Energy Working Group has developed 15 web services to disseminate our data and knowledge.
The GEOSS common infrastructure provides the necessary components to ensure a full interoperability process. Promoting data and services to a broad community of users is a key asset from a data provider perspective. The data provider starts by deploying web services on a community portal. Then it generates the ISO metadata using the free Inspire metadata editor. Metadata are hosted inside a web-accessible folder for a simple catalog approach. The web-accessible folder is then registered in the GEOSS registry. Once registered, this web-accessible folder is ready to be harvested by GEOSS crawlers, allowing data and services to be accessed by users on the GEO portal.
As a user, I'm accessing the GEOSS portal and I'm looking for solar radiation-related data. Among the results, I discover that there is a service specific to the sealing of solar power plants. By invoking this service on the Project Measure website, I access an interface where I can select an area of interest. I select the scale of the maps I want to retrieve. The service offers various layers for my study.
Data come from various sources. The solar radiation data come from Mines Paris Tech community portal. Geographical and environmental layers are provided by other partners like DEMIS and CISIN. Full intellectual property right and credits are displayed in the corresponding tabs. When all the parameters are set, clicking the Compute Web Service button will start the fetching processing of all the layers, enabling a web service chaining mechanism. When the retrieval process is finished, user can download the layers as a KMZ archive file.
Double-clicking on the archive will prompt the Google Earth application to view the various information layers. I can have a first glance at the various layers. I ingest these layers into a geographical information system, such as ArcView, to perform computations on the most favorable areas where to sit a solar plant. I will then exploit these results in my specialized tools for solar system sizing and produce reports on the favorable sites and their energy production. So GEOSS is a very promising system for my daily work.
This hand-to-hand scenario gathers data provider and a consulting company under the GEOSS umbrella by implementing GEOSS interoperability recommendations. Within this scenario, we have addressed the full scope from web service development to customized applications. The renewable energy community benefits now from numerous web services and dedicated applications to retrieve data and maps.